Now, with apologies, there's a bunch of physics in this board as well, but over here we have an analysis of if Q then P. And of course, if Q then P means that if it's a Q, it has to be a P. That means the Q circle has to be inside the P circle. And we want to look at the inverse statement to if P then Q. This is the converse of if P then Q. Well, the inverse of if P then Q is the contrapositive of the converse. If you want to look at it that way, we reverse it and change the truth values. This is the inverse of the statement if P then Q. We just change the truth values. It's also the converse, the contrapositive of the converse if Q then P. Okay. So we're really showing, or trying to show, or trying to determine whether, although we've already established it with the truth tables, try to determine whether the converse of if P then Q and the inverse of if P then Q are equivalent. So we draw a picture for the converse of if P then Q. And maybe it would be a little clearer, I think it was in the context of the class. This is the converse of if P then Q. This is the inverse. Of if P then Q. And we're trying to test whether the converse of if P then Q is equal to the inverse. And again, I noted that the inverse of if P then Q is the contrapositive of if Q then P. That would establish it already because we know a statement now is equivalent to its contrapositive. No matter what the antecedent and consequent are, the contrapositive is the negation of the consequent, then if the negation of the consequent, then the negation of the antecedent, and that would be sufficient proof, but let's look at it in terms of Venn diagrams. Okay, the converse of if P then Q is if Q then P, and it's drawn this way, if Q then P. We first note why do I have two circles here? Okay, I'm not sure why I drew two. I mean, I understand the statements. Okay, here is a not Q that isn't a not P. Okay, so we can't say if not Q, then not P. And then I just drew another X in the same region saying that, okay, this is a P, but it isn't a Q. So we can't say if it's a P, then it's a Q. Okay, so that our original statement can't be assured. The contrapositive of our original statement can't be assured. Now here is a not P, and we note that any not P, anything outside the P circle, also has to be outside the Q circle. So any not P has to be a not Q. Okay, so any not P is also a not Q. What does that tell us? It tells us that if not P, then not Q. Okay, we can't find a not P that isn't a not Q. Anything outside the P circle is outside the Q circle. It then follows that if not P, then not Q. So we can establish the truth of this, and this establishes that the converse of our original statement and the inverse of our original statement are equivalent. We already did that with truth tables, but right there's a picture of the kind of reasoning that we would use.